April 15th, 1944. 29,000 feet above the Dutch coast. Hauptmann Wilhelm Jonnen's hands tightened on the control column of his Messerschmitt Bf 110 night fighter as he watched something impossible slice through the afternoon sky. The object, if it could be called that, had no propeller, no visible means of propulsion, yet it was moving faster than anything he had seen in 5 years of combat. The veteran night fighter ace with 34 confirmed kills blinked hard, certain his oxygen-starved brain was playing tricks. Then his wingman's voice crackled through the radio, strained with confusion and something approaching fear. Herr Hauptmann, what in God's name is that thing? Jonnen had no answer. What he was witnessing was supposed to be impossible. Fighter aircraft required propellers. Everyone knew this. The laws of physics demanded it. Yet this strange machine with its blunt nose and swept wings was accelerating away from his formation as if they were standing still, trailing no exhaust smoke, making no sound he could hear over his own engines, simply vanishing into the distance at a speed that defied every assumption about aerial warfare. Unknown to Jonnen, he had just witnessed the future of aviation. What he saw was a Gloster Meteor, the Allies' first operational jet fighter, on a test flight over occupied Europe. Within months, German pilots would face these revolutionary machines in combat, and their reactions would range from stunned disbelief to outright panic as they realized the propeller-driven fighter, the weapon that had defined aerial combat since 1914, was suddenly obsolete. The story of how jet-powered aircraft transformed from theoretical concept to combat reality, and how German pilots, the most experienced fighter force in the world, reacted when they encountered machines that rewrote the rules of physics, is one of the most dramatic technological revolutions in military history. It's a story of British innovation meeting German desperation, of experimental weapons thrown into combat before anyone truly understood their capabilities, and of veteran pilots whose hard-won experience suddenly meant nothing when facing machines that could outrun, outclimb, and outmaneuver anything they had ever flown. The origins of the jet revolution began not in response to German innovations, but despite them. While Germany's Messerschmitt Me-262 typically receives credit as the world's first operational jet fighter, the reality is more complex. Britain's Gloster Meteor actually entered squadron service on July 12, 1944, weeks before the Me-262 became operational. The Meteor's development had been slower and more methodical than Germany's desperate rush to field jet technology, but this British caution would prove surprisingly effective. The Air Ministry specification F940, issued in February 1940, called for a single-seat fighter powered by Frank Whittle's revolutionary turbojet engine. Gloster Aircraft Company, which had been collaborating with Whittle since 1939, submitted a design for a conventional-looking fighter fitted with 2 engines mounted in the wings. The twin-engine configuration was necessary because early turbojets were woefully underpowered, producing barely 1,000 pounds of thrust each, roughly equivalent to a single piston engine. The first Meteor prototype flew on March 5, 1943, piloted by Michael Daunt, Gloster's chief test pilot. His report was cautious but promising. The aircraft handles conventionally at low speed. Acceleration in level flight is remarkable once the engines spool up. Maximum speed achieved was 380 miles per hour at 10,000 feet, though I suspect considerably more is possible at altitude. The controls are light and responsive. The absence of propeller torque and engine vibration is extraordinary, almost eerie. One feels as though one is being pushed by an invisible hand. The landing approach requires different techniques. Without propeller drag to slow the aircraft, speed management is critical. That invisible hand Daunt described was thrust produced not by a spinning propeller, but by superheated exhaust gases expelled at tremendous velocity through a narrow nozzle. The principle was simple in theory, nightmarishly complex in practice. Air entered the engine through an intake, was compressed by a series of rotating blades, mixed with fuel and ignited in a combustion chamber, then expelled through a turbine that drove the compressor before exiting through the exhaust nozzle. The entire process occurred thousands of times per second, with turbine blades spinning at 10,000 revolutions per minute in temperatures exceeding 1,500 degrees Fahrenheit. Early jet engines were temperamental beasts prone to catastrophic failures. Turbine blades, subjected to enormous centrifugal forces and extreme heat, would sometimes disintegrate, sending shrapnel through the engine casing. The fuel control systems were primitive, and throttle movements had to be gentle to avoid flameouts or compressor stalls. Worst of all, the engines consumed fuel at an appalling rate, limiting endurance to barely 45 minutes. But the performance, when everything worked, was revolutionary. By June 1944, the Meteor F1 variant equipped with Rolls-Royce Welland engines could reach 410 miles per hour at 30,000 feet, speeds that only the fastest piston fighters could achieve in a full-power dive. More significantly, the Meteor could maintain these speeds for sustained periods, whereas piston engines quickly overheated at maximum power settings. No. 616 Squadron Royal Air Force, based at Culm Head in Somerset, received the first operational Meteors in July 1944. The pilots, all experienced fighter veterans with combat time in Spitfires and Typhoons, approached their new mounts with a mixture of excitement and apprehension. Flight Lieutenant Andrew McDowell, who had become one of the first Meteor aces, recorded his initial impressions. Climbing into the Meteor for the first time is disorienting. The cockpit sits high off the ground, the nose is blunt, the view forward is excellent, but the wing obscures the view downward. The engine start procedure is unlike anything I've experienced. You press the starter button, the turbine begins to wind up with a rising whine, fuel is introduced, and suddenly you're shoved back in your seat as thrust builds. There's no propeller blast, no engine vibration, just this smooth, powerful push. Taxiing requires caution. The engines respond to throttle inputs with a delay of several seconds, so you must anticipate your power needs. On takeoff, the acceleration is startling. You're pushed back into your seat with constant force as speed builds. The controls remain light and responsive throughout. At 110 miles per hour, the nose lifts easily, and you're airborne with over half the runway remaining. The climb is where the Meteor truly impresses. At full power, the rate of climb exceeds 4,000 feet per minute at sea level. You simply point the nose up and the aircraft goes vertical with no loss of control authority. In level flight at altitude, the sped builds effortlessly. 350, 400, 450 miles per hour, and still accelerating. The controls remain responsive at speeds where Spitfires become sluggish. Most extraordinary is the absence of vibration. You're sitting in a silent, smooth cocoon, being pushed through the sky by invisible forces. But 616 Squadron quickly discovered the Meteor's limitations. The engines were maintenance nightmares, requiring careful temperature management and frequent inspections. Fuel consumption limited mission duration to barely half an hour in combat conditions. The 420mm Hispana cannon, Britain's standard fighter armament, proved difficult to harmonise due to the jet's high speed. Most concerning, the Meteor's thick straight wings created enormous drag at high speed, limiting top speed far below what the engines theoretically could achieve. The first operational Meteors were restricted to home defence duties, specifically hunting V-1 flying bombs that were terrorising southern England. The V-1, Hitler's revenge weapon, was essentially a pilotless jet aircraft that flew at about 400 miles per hour at low altitude, making it extremely difficult for conventional fighters to catch. The Meteor, with its superior speed, seemed ideal for the mission. On August 4, 1944, Flying Officer Dean achieved the Meteor's first kill, destroying a V-1 over Kent. But the victory was unconventional. Dean had closed to firing range, pressed the trigger, and discovered his guns had jammed. Rather than let the flying bomb continue toward London, he flew alongside it, carefully positioned his wingtip under the V-1's wing, and tipped it over, sending the robot bomb into a fatal dive. The manoeuvre, later dubbed the Meteor tip, became a standard tactic when ammunition ran out. Flying Officer Roger, flying Meteor EE-227, achieved the first gun kill of a V-1 on August 6th, closing to 200 yards and firing a short burst that detonated the flying bomb's 1,170-pound warhead. The explosion was so violent that Roger's Meteor was thrown skyward by the blast, several panels blown off the wings, but the sturdy jet aircraft recovered and returned safely to base. By September 1944, No. 616 Squadron had destroyed 13 V-1 flying bombs without loss, but the Air Ministry was eager to test the Meteor against German aircraft. The squadron moved to Manston in Kent, then to Melsbrook in Belgium in January 1945, finally positioning the revolutionary fighters where they might encounter the Luftwaffe. German pilots were aware that the Allies were developing jet aircraft, but intelligence was fragmentary and often dismissed as exaggerated. Oberst Johannes Steinhoff, a veteran fighter commander with over 170 victories, received a briefing in December 1944 about Allied jet development. The report was sceptical. Intelligence suggests the British have developed a twin-engine jet fighter designated Meteor. Performance is reported as superior to conventional fighters, though specific data is lacking. Assessment: the British typically favour conservative designs and reliable technology. Their jet, if operational, is likely slower and less capable than our Me-262. The Luftwaffe High Command believed German jet technology was at least 2 years ahead of the Allies. This confidence was not entirely misplaced. The Messerschmitt Me-262, Schwalbe, or Swallow, had been in development since 1938 and had achieved speeds exceeding 540 miles per hour in testing, far faster than any Allied piston fighter. But German pilots flying the Me-262 in late 1944 were discovering that revolutionary technology came with revolutionary problems. Lieutenant Franz Stigler, who transitioned from the Messerschmitt Bf 109 to the Me-262 in December 1944, found the jet both thrilling and terrifying. The first time you advance the throttles on a Me-262, you're convinced you've made a terrible mistake. The acceleration is violent, unnatural. You're pushed back in your seat with a force that makes breathing difficult. The noise is incredible. A screaming howl that penetrates your helmet and makes your teeth vibrate. The instruments blur before your eyes as you accelerate down the runway. At 110 miles per hour, you rotate, and suddenly you're climbing at an angle that would stall any piston fighter. In 90 seconds, you're at 20,000 feet. In level flight, the Me-262 is sublime. Controls are light and responsive. The speed is intoxicating. You can outrun anything in the sky. But it's also a widowmaker. The Jumo 004 engines are temperamental, prone to flameouts if you move the throttles too quickly. They overheat if you hold full power too long. The turbine blades fail without warning, usually catastrophically. We lost more pilots to engine failures than to enemy action in my squadron. The first encounter between a Meteor and German fighters occurred on January 19, 1945, near Nijmegen, Holland. Flight Lieutenant Watts, leading a patrol of 4 Meteors from 616 Squadron at 12,000 feet, spotted a pair of Focke-Wulf FW-190s attacking British ground forces. Watts banked hard toward the German fighters, pushing his throttles forward. The Meteor responded instantly, accelerating past 400 miles per hour in level flight. The German pilots, veterans of the Eastern Front with dozens of kills each, saw the approaching aircraft and assumed they were conventional fighters. They split, one diving for the deck, the other climbing to gain altitude advantage. Watts followed the climbing FW-90, watching his airspeed indicator climb to 420, then 440 miles per hour. The German fighter, its BMW 801 radial engine already at maximum power, was at its absolute performance limit. The Meteor was just getting started. At 18,000 feet, Watts closed to 300 yards, centered the FW-190 in his gun sight, and pressed the firing button. The 4 20mm cannon erupted, sending a stream of explosive shells into the German fighter. The FW-190's left wing folded upward, torn away by the explosive impacts. The aircraft snap-rolled violently and plunged earthward, trailing fire and smoke. The pilot never escaped. The second FW-190, having witnessed his wingman's destruction, was diving for the safety of low altitude when Flying Officer McDowell's Meteor caught him at 4,000 feet. McDowell's combat report was clinical. Closed to 250 yards at 450 miles per hour. Target attempted violent evasive maneuvers, fired 2-second burst, observed strikes along fuselage and wing route. Target exploded. No parachute observed. Return to base, ammunition expenditure 180 rounds. Total engagement time from initial contact to second kill, 47 seconds. The 2 German pilots never knew what hit them. From their perspective, they had engaged what appeared to be conventional Allied fighters, only to find themselves being chased down by aircraft that accelerated past them as if they were standing still. The FW-190, one of Germany's finest fighters with a top speed of 408 miles per hour, was simply outclassed. News of the engagement spread quickly through Luftwaffe units in the region. The reports were confused and contradictory. Some pilots claimed the British had deployed captured Me-262s. Others insisted they had encountered a new type of conventional fighter. Intelligence officers struggled to assemble a coherent picture from the fragmentary accounts. Hauptmann Heinz Baer, one of Germany's top aces with over 200 victories, encountered Meteors on February 9, 1945, while flying an Me-262 near Osnabrück. His experience would fundamentally alter German perceptions of Allied jet technology. Baer was leading a Schwarm, a 4-aircraft formation, on a bomber interception mission when his wingman called out unidentified aircraft at 10 o'clock high. Baer scanned the sky and spotted 4 twin-engine aircraft in loose formation at about 25,000 feet. His first thought was that they were Mosquito light bombers, a common Allied type. But something about their silhouette was wrong. The wings were too thick, the engines too close to the fuselage, the overall proportions unfamiliar. Baer decided to investigate. He banked toward the formation and advanced his throttles, accelerating his Me-262 to about 500 miles per hour. The 4 aircraft, which he could now see were fighters of some kind, immediately turned toward him in perfect coordination. What happened next shocked Baer to his core. The unidentified fighters accelerated, not gradually, not reluctantly, but instantly and aggressively. Within seconds they had closed the distance and were positioning for an attack. Baer, flying the fastest operational fighter in the world, found himself being pursued by aircraft that matched his speed effortlessly. Baer's combat report, filed immediately upon landing, captured his astonishment. Encountered 4 twin-engine fighters of unknown type at 25,000 feet. Initially assessed as Mosquitoes. Upon closing, identified as jet-powered aircraft. Silhouette distinct from Me-262, engines mounted in wings rather than fuselage. Thick straight wings, single tail, 4 cannon visible in nose. Aircraft demonstrated performance equal to or exceeding Me-262. Maximum speed observed approximately 490 miles per hour. Acceleration comparable to Me-262. Climb rate excellent. Maneuverability at high speed superior to Me-262. Assessment: British or American jet fighter. Operational status confirmed. Performance characteristics exceptional. Threat level extreme. Baer had survived the encounter only because the British pilots, probably on their first jet versus jet engagement, had been too cautious in pressing their attack. The Me-262's superior speed at altitude allowed Baer to disengage, diving away at full throttle, but the experience left him badly shaken. Germany's technological advantage, the Me-262, that was supposed to be 2 years ahead of anything the Allies possessed, had just been matched. The news sent shockwaves through the Luftwaffe High Command. If the British had operational jet fighters comparable to the Me-262, German air superiority already critically eroded was in serious jeopardy. What made the situation even more alarming was that the British jet, unlike the Me-262, appeared to be fully operational without the crippling engine reliability problems that plagued German jets. Reich Marshal Hermann Göring, head of the Luftwaffe, demanded a full intelligence assessment. The report, delivered in mid-February 1945, painted a sobering picture. The British Meteor jet fighter has been operational since mid-1944, predating our Me-262 by several weeks. Approximately 200 aircraft have been produced. Performance is comparable to Me-262 in most parameters, though maximum speed appears lower, estimated at 490 miles per hour versus our 540 miles per hour. However, the Meteor demonstrates superior reliability. British jet engines, while less powerful, are more dependable than our Jumo 04 units. The Meteor's operational availability rate is estimated at 75%, compared to our Me-262's 30%. Most significantly, the British appear to have solved the engine life problem that plagues our jets. Meteor engines reportedly achieve 180 hours between major overhauls, compared to 25 hours for our Jumo 004s. German pilots began encountering Meteors with increasing frequency in March 1945, as 616 Squadron ramped up operations over Germany. The psychological impact on Luftwaffe pilots was profound. For years, German fighter pilots had enjoyed technological superiority, flying machines that could outperform Allied fighters in most parameters. Now they faced aircraft that could outrun, outclimb, and often outmaneuver their conventional fighters, while the vaunted Me-262, Germany's wonder weapon, was grounded as often as it flew due to mechanical problems. Lieutenant Walter Haginer, flying a Focke-Wulf Efferdogte 190 D9, one of Germany's best late-war fighters, encountered Meteors on March 12, 1945, near Rhine. His account captures the helplessness German pilots felt when facing jet-powered opponents. We were climbing to intercept a bomber formation when my number 3 called out fighters diving from above. I looked up and saw 4 aircraft in a steep dive coming incredibly fast. My first thought was Me-262s, our own jets. Then I realized the silhouette was wrong. These were enemy aircraft. I immediately called for the swarm to break and we split in 4 directions. The jets. I could see now they were jets from the absence of propellers, pulled out of their dive at impossible speed and climbed vertically back to altitude. The entire maneuver took perhaps 15 seconds. Then they dove again. This time, they opened fire. I saw one of my men simply explode, his FW-190 disintegrating under a hail of cannon shells. The rest of us dove for the deck, our only chance of escape. At low altitude, we might hide in ground clutter or use terrain to break contact. But even diving at maximum speed, over 450 miles per hour, the jets followed us down. I was pulling over 6 Gs in violent evasive maneuvers, my vision greying at the edges, my aircraft shuddering on the edge of structural failure. The jet behind me matched every maneuver effortlessly. I saw his cannon flashes, felt impacts along my right wing. Somehow I made it to a patch of forest and managed to lose him by flying barely 50 feet above the trees. When I landed, my aircraft was riddled with holes. My entire swarm, 4 experienced pilots with over 300 combined victories, had been destroyed or scattered by 4 British jets in less than 3 minutes. We never even got our sights on them. The Meteor's effectiveness was not primarily due to superior speed, though it was certainly faster than any German piston fighter. Rather, it was the combination of speed, sustained performance, and the psychological impact of facing an enemy who could engage or disengage at will. German pilots were accustomed to combat where success required outmaneuvering opponents in turning fights. Against jets, turning was suicide. The jet would simply extend away, climb back to altitude, and attack again at leisure. Oberst Walter Dahl, commanding Jagdgeschwader 300, a night fighter unit that had been hastily converted to day operations, reported to headquarters in March 1945. Conventional fighters cannot effectively engage Allied jets. Our maximum speed at combat altitude is approximately 400 miles per hour. The British jet's cruising speed exceeds this. Any engagement is entirely at their discretion. They attack from altitude with speed advantage, make a single high-speed pass, and extend away before we can react. If we evade the first attack, they simply climb back to altitude and attack again. Our pilots are experienced, our aircraft are capable, but we cannot catch what we cannot reach. Losses are becoming unsustainable. I must recommend that conventional fighters be withdrawn from areas where Allied jets operate. Dahl's recommendation was rejected. Germany simply didn't have enough Me-262s to contest Allied air superiority, and what jets they did have were often grounded by lack of fuel, spare parts, or trained pilots. Conventional fighters, obsolete or not, had to continue operations. The result was a massacre. By April 1945, any German fighter that encountered Meteors faced overwhelming odds. The Meteor pilots, now experienced in jet versus piston tactics, had developed efficient kill methods. Flight Lieutenant McDowell, who would end the war with 5 jet-powered kills, described the standard Meteor attack profile. We patrol at 30,000 feet where German piston fighters struggle to operate. When we spot enemy aircraft below, we position ourselves up-sun for maximum surprise. The attack dive begins from directly above or slightly behind the target. We accelerate to 450 to 500 miles per hour in the dive, far faster than any German fighter can achieve. At this speed, deflection is minimal. You simply point at the target and fire. The closing rate is so high that German pilots often never see us coming. The first indication they have of our presence is cannon shells tearing through their aircraft. We open fire at 400 yards and hold fire until 200 yards, then pull up sharply. The zoom climb carries us back to altitude within seconds. If the target survives, which is rare, we simply repeat the process. The German has no counter. He cannot climb to our altitude. He cannot outrun us. He cannot outmaneuver us at the speeds we engage. It's not really a fight, it's an execution. The moral implications of this lopsided combat troubled some Meteor pilots. Squadron leader Watts confided to his diary in April 1945, "I joined the RAF to fight, to test myself against skilled opponents in fair combat. What we're doing now doesn't feel like fighting, it feels like murder. These German pilots are brave men, often very experienced, but they're flying, obsolete machines against technology they cannot counter. When I shoot one down, there's no sense of victory, only sadness at the waste. They never had a chance." But the war continued, and Meteor squadrons continued their deadly work. By April 1945, 2 more RAF squadrons, 504 and 74, had converted to Meteors, giving the Allies over 100 operational jet fighters in Europe. German intelligence estimated that for every Meteor actually encountered, 10 more missions were aborted because German pilots reported jets in the area and refused to engage. The psychological impact extended beyond just avoiding combat. Luftwaffe pilot training, already abbreviated to dangerous levels due to fuel shortages, essentially collapsed in early 1945. New pilots arriving at operational units were told they might face British jets. The knowledge that they could encounter enemies they had no chance of defeating caused several pilots to refuse combat flying. Courts-martial for cowardice increased dramatically in the war's final months, but Luftwaffe commanders privately acknowledged that refusing to fly obsolete fighters against jets was rational, not cowardly. Hauptmann Hans Joachim Jabs, a night fighter ace with 50 victories who transitioned to day operations in the war's final weeks, summarized the situation bluntly. Asking conventional fighter pilots to engage Allied jets is asking them to commit suicide. The performance gap is simply too large. It would be like asking infantry to charge machine gun nests with swords. Technically possible, occasionally successful, but ultimately futile. The British jets are destroying our remaining experienced pilots, the instructors we desperately need to train replacements. Every loss is irreplaceable. We're not fighting a war anymore. We're watching our Air Force be systematically exterminated. Ironically, while German pilots feared the Meteor, British pilots considered it merely adequate. The thick, straight wings that generated so much drag prevented the Meteor from achieving its full potential. Test pilots who flew captured Me-262s after the war universally agreed the German jet was faster and more advanced, if less reliable. But reliability mattered enormously in operational service. And Me-262 that spent 70% of its time grounded for maintenance was far less effective than a Meteor that flew whenever needed. The numbers told the story. Germany produced approximately 1,400 Del and Me-262s during the war. Due to maintenance issues, training difficulties, and fuel shortages, probably no more than 300 were ever operationally available at any given time. Britain produced about 280 Meteors by war's end, but maintained an operational availability rate 3 times higher than the Me-262. The result was that Meteors actually flew more combat sorties than Me-262s, despite being fewer in number. The final weeks of the war saw Meteors ranging deep into Germany, attacking targets that conventional fighters could no longer reach due to dense, anti-aircraft defences and aggressive Luftwaffe interception. The jets could simply fly too high and too fast for ground fire to track them effectively, and German fighters, when they appeared, were brushed aside. On April 25, 1945, Flight Lieutenant Watts led a 4-ship Meteor formation on an armed reconnaissance mission over northern Germany. Near Hamburg, they encountered what would be one of the last organised Luftwaffe formations of the war, a dozen Focke-Wulf FW-190s attempting to intercept a bomber formation. Watts positioned his flight above and behind the German fighters, then attacked. The combat lasted 90 seconds. 4 FW-190s were destroyed, the rest scattered. Not a single Meteor was hit. Watts reported afterward. They didn't even fight back. They saw us coming, broke formation, and dove for the ground. We followed them down and picked them off one by one. It was slaughter, not combat. These pilots knew they couldn't win. They were just trying to survive. Most didn't. The psychological impact of the Meteor on German fighter pilots in the war's final months cannot be overstated. These men, many of them veterans of years of combat, had their tactical expertise rendered obsolete overnight. Everything they had learned about energy management, deflection shooting, and air combat maneuvering became irrelevant when facing an opponent who could dictate every aspect of the engagement. Post-war interviews with surviving Luftwaffe pilots reveal a common theme. The jets represented not just a technological challenge, but an existential crisis. Lieutenant Heinz Knoke, who survived the war after flying over 400 combat missions, wrote in his memoir, "When we first heard rumours about British jets, we didn't believe them. Then we saw them. Then we died facing them. The Meteor killed more than pilots. It killed hope. Every man who went up knowing jets were in the area knew he might not return. Not because he lacked skill or courage, but because he was flying a biplane in a jet age. The feeling of helplessness was overwhelming. You could be the best pilot in the Luftwaffe, with perfect tactical awareness and lightning reflexes, and it didn't matter. The British pilot didn't need to outfight you. He just needed to catch you, and you couldn't escape." In the war's final days, some German units refused to fly when meteors were reported in their area. This wasn't cowardice. It was rational calculation. The Luftwaffe was finished. Everyone knew it. Dying heroically in an unwinnable fight served no purpose except to eliminate experienced pilots who would be needed to rebuild after the war. Officers who court-martialed pilots for refusing suicidal missions were themselves often shot by their own men in the chaos of Germany's collapse. The Meteor's combat record was relatively modest by numerical standards. 616 Squadron claimed 46 aerial victories during the war, most against V-1 flying bombs and conventional aircraft. But this number drastically understates the aircraft's impact. For every German fighter shot down by a meteor, dozens more were prevented from flying by the mere threat of jet interception. Entire fighter wings remained grounded or were withdrawn from frontline service to avoid jet encounters. The Meteor's greatest achievement was not the aircraft it destroyed, but the missions it prevented and the moral collapse it induced in its opponents. The post-war assessment by Allied intelligence validated this view. A report compiled in July 1945, analysing Luftwaffe combat effectiveness, noted the introduction of Allied jet fighters in January 1945 had a disproportionate impact on German fighter operations. While jets accounted for less than 5% of actual German aircraft losses in the final months, they were responsible for an estimated 40% reduction in Luftwaffe sortie rates. German fighter pilots, when debriefed after capture, consistently cited fear of Allied jets as a primary factor in declining morale and increasing combat refusals. The psychological impact of facing technologically superior opponents cannot be quantified, but was clearly significant in hastening the Luftwaffe's final collapse. German pilots, when interviewed after the war, were universally respectful of the Meteor, even though many had never actually encountered one in combat. The reputation alone was enough. Oberst Johannes Steinhoff, who had dismissed early intelligence reports about British jets, wrote in his post-war memoir, "I was wrong about the British. I assumed their conservative nature would prevent them from fielding jet technology quickly. In reality, their methodical approach produced a more reliable, more operationally effective fighter than our rushed Me-262 program. The Meteor may have been slower than the Schwalbe in absolute terms, but it was faster where it mattered, getting into the air and staying there. Our pilots feared it more than they feared the Me-262's speed, because the Meteor was always there, always ready, always hunting. The technical lessons learned from the Meteor would shape jet fighter development for the next decade. The British discovered that straight wings, while producing excessive drag at high subsonic speeds, provided excellent low-speed handling characteristics crucial for carrier operations and rough field performance. The twin-engine configuration, initially chosen due to the low thrust of early jets, proved advantageous for safety and redundancy. Engine placement in the wings rather than the fuselage created challenges for centre of gravity management, but simplified maintenance and allowed for easier engine changes. Most significantly, the Meteor demonstrated that jet fighters could be reliable, maintainable, and operationally effective, not just experimental hot rods suitable only for test pilots. The Meteor's design philosophy, prioritising operational utility over maximum performance, would influence British fighter design for generations. The Hawker Hunter, English, Electric Lightning, and even the modern Eurofighter Typhoon all reflect lessons learned from the Meteor program. For German pilots who survived the war, the memory of facing jets remained vivid decades later. At a 1975 reunion of Luftwaffe veterans in Munich, the subject of Allied jets came up during an informal discussion. The reaction was telling. General Lieutenant Adolf Galland, former general of fighters who had flown Me-262s extensively, was asked about the Meteor. His response: "The Meteor was the aircraft we should have built. Not as fast as the Schwalbe, but fast enough. Not as advanced, but advanced enough. Most importantly, reliable enough to actually fight a war." Our Me-262 was a technical masterpiece that spent most of its time on the ground. Their Meteor was a practical weapon that flew every day. In war, the good weapon you can use beats the perfect weapon you cannot. When British pilots encountered Meteors at low altitude, they learned we had not achieved jet superiority, only jet parity. Our advantage was gone. Any remaining confidence we had disappeared with it. The Gloster Meteor served in the Royal Air Force until 1957, an extraordinary service life for a design that first flew in 1943. Updated variants set speed records, served as trainers, and equipped dozens of air forces worldwide. But its greatest achievement remained those final months of World War II, when its appearance over Germany induced something approaching panic in the world's most experienced fighter force. The transformation of German attitudes toward the Meteor mirrored their changing fortunes in the war. In December 1944, when rumours first circulated about British jets, they were dismissed as propaganda. In January 1945, when the first confirmed encounters occurred, they were assessed as technologically interesting, but operationally limited. By March 1945, they were recognised as deadly threats to be avoided. By April 1945, they had become symbols of inevitable defeat, flying manifestations of Allied material superiority. German pilots, who had entered the war with technological advantages over their opponents, ended it facing enemies they could neither catch nor fight. The story of the Meteor and German pilots' reactions to it is ultimately about the obsolescence of experience in the face of revolutionary technology. The Luftwaffe pilots who faced Meteors in 1945 were among the most skilled in aviation history, veterans of 6 years of continuous combat who had developed fighter tactics to an art form. Yet when confronted with aircraft that operated by entirely different rules, their expertise meant nothing. You cannot outmaneuver an opponent who doesn't need to maneuver. You cannot outshoot an enemy you cannot catch. You cannot win a fight that is entirely at your opponent's discretion. The Meteor taught this lesson brutally and efficiently. When Flight Lieutenant Watts shot down his final German fighter on April 27, 1945, 4 days before Germany's surrender, he noted in his combat report, enemy pilot appeared experienced based on flight characteristics and initial evasion attempts. However, once committed to the engagement, he had no effective counter to jet attack. Destroyed after approximately 20 seconds of combat. Total ammunition expenditure, 47 rounds. That final kill, a routine entry in a combat report, encapsulated the entire Meteor experience from the German perspective. An experienced pilot flying a capable aircraft had been destroyed in 20 seconds by an enemy he could not effectively engage. His years of training, his accumulated combat wisdom, his tactical expertise, all rendered irrelevant by a machine that simply operated in a different performance realm. This was the future of air combat, and German pilots saw it before anyone else. In April 1943, German aces had laughed at American P-47 Thunderbolts they thought were obsolete. By April 1945, they were the ones flying obsolete machines, being systematically destroyed by aircraft that seemed to mock every assumption they had ever made about aerial warfare. The laughter had stopped. The thunder of approaching Meteors, a distinctive howling scream produced by the Rolls-Royce Derwent turbojets, became as feared as the roar of P-47s had been a year earlier. German pilots called it the death whistle. When you heard it, you knew you had seconds to live unless you could reach ground level or cloud cover. The sky belonged to the jets, and propeller-driven fighters were simply obsolete targets waiting to be destroyed. The Meteor didn't win the war. The war was already won by April 1945 when Meteors began operations in earnest over Germany, but it did something perhaps more psychologically devastating. It showed German pilots that even if they had somehow survived, even if some miracle had allowed Germany to continue fighting, the future belonged to their enemies. The technological race was over, and Germany had lost. The final documented encounter between a Meteor and a German fighter occurred on May 3, 1945, 5 days before Germany's unconditional surrender. Flying Officer Ted Hooker of 616 Squadron, was returning from a patrol over northern Germany when he spotted a lone Messerschmitt Bf-109 at low altitude, apparently attempting to reach a hidden airfield. Hooker dove on the German fighter, but before he could open fire, the 109 pilot rolled inverted and bailed out. His aircraft, undamaged and with fuel remaining, crashed into a field. Hooker circled the descending parachute, confused by the German pilot's decision to abandon a perfectly functional aircraft. Later analysis suggested the pilot had simply given up. Seeing the approaching Meteor, knowing he had no chance of escape or survival in combat, he had chosen to save his own life rather than die pointlessly in the war's final days. This surrender without fighting, this acknowledgement that resistance was futile, represented the ultimate victory of jet technology over conventional fighters. The battle didn't need to be fought because the outcome was predetermined. Post-war technical intelligence teams that examined both the Meteor and the Me-262 provided fascinating insights into the different design philosophies. The British had prioritised operational reliability, ease of maintenance, and pilot safety. The Meteor featured engines that could be removed and replaced in under 2 hours by a ground crew with basic tools. The cockpit was spacious and well laid out with conventional instruments. The controls were harmonised to feel similar to piston fighters, easing pilot transition. The structure was overbuilt, capable of withstanding stresses far beyond normal flight operations. In contrast, the Me-262 was a pure performance machine. Every aspect of its design prioritised speed and firepower over operational considerations. Engine changes required specialised equipment and took days. The cockpit was cramped with poorly arranged instruments. The controls required extensive retraining because they behaved nothing like conventional fighters. The structure was stressed to the limit, with minimal safety margins. One technical report noted with dry British understatement, "The German jet represents the triumph of engineering ambition over operational practicality. It is faster, more advanced, and more impressive than the Meteor. It is also less reliable, more difficult to maintain, and more dangerous to fly. In combat, the more reliable weapon is generally the more effective weapon. The Meteor demonstrates this principle admirably, but this assessment, while technically accurate, missed something important that German pilots understood instinctively. The Me-262, for all its flaws, was born of desperation. Germany needed a miracle weapon that could somehow reverse the tide of an already lost war. They needed maximum performance regardless of cost or reliability. The Meteor, conversely, was born of confidence. Britain could afford to prioritise reliability because they knew they would win the war through sustained effort, not miracle weapons. The different design philosophies reflected the different strategic situations of their creators. German pilots who flew against meteors and survived developed enormous respect for both the aircraft and its pilots. Hauptmann Heinz Baer, who had encountered meteors in his Me-262 and lived to compare the two jets, offered perhaps the most balanced assessment in a 1952 interview. The Me-262 was faster, about 50 miles per hour faster at altitude. It had better guns, 30mm cannon that could destroy a bomber with a few hits. It looked more futuristic, more aggressive. But the Meteor was the better fighter in 1945 because it could actually fight. Our jets were often grounded. Theirs flew constantly. Our jets required careful handling. Theirs could be flown aggressively. Our jets were flown by carefully selected pilots with extensive training. Theirs were flown by ordinary squadron, pilots after minimal jet conversion. The Meteor wasn't a better aircraft, it was a better weapon system. There's a difference. This distinction between aircraft and weapon system would become central to jet fighter development in the post-war era. The Soviet Union, examining both German and British jets captured at war's end, initially favoured copying German designs due to their superior performance. But operational experience with early Soviet jets like the MiG-9 revealed that German-style design philosophy produced fighters that were difficult to manufacture, maintain, and operate. Later, Soviet jets increasingly incorporated British-influenced design elements, prioritising operational utility. The Americans, who'd been slower to develop jet technology during the war, learned from both approaches. Aircraft like the F-86 Sabre combined German swept-wing aerodynamics with British reliability engineering, creating fighters that were both fast and operationally effective. The human cost of the Meteor's operations was relatively light on the British side. 6 on 16's squadron lost only 3 aircraft to enemy action during its entire operational service, though several more were lost to accidents as pilots learned to handle jet fighters' different flight characteristics. But the German side paid heavily. While exact numbers are impossible to determine in the chaos of the war's final months, Luftwaffe records suggest at least 50 conventional fighters were lost in direct combat with Meteors, with hundreds more destroyed or damaged in attacks where jet fighters were present, but individual aircraft could not be definitively identified. More significantly, an estimated 200 to 300 German fighter sorties were aborted or never flown due to reports of Allied jets in the area. Each cancelled sortie represented bombers that reached their targets unopposed, ground forces that operated without air cover, and a psychological victory for Allied air power. The impact on individual German pilots varied. Some, like Heinz Baer, survived encounters with Meteors and lived long post-war lives, becoming respected voices in aviation history. Others, like the unknown pilot who bailed out rather than face Ted Hooker's Meteor in May 1945, disappeared into the chaos of Germany's collapse, their names lost to history. Still others, veterans of years of combat who had survived Spitfires, Hurricanes, P-47s and P-51s, died in the war's final weeks, shot down by British jets flown by pilots half their age with a tenth of their experience. The unfairness of these final kills haunted some Meteor pilots. Squadron leader Andrew McDowell, who ended the war with 5 confirmed victories, 4 against conventional German fighters and 1 against a V-1, spoke about this in a 1983 interview. "Every pilot I shot down was probably more experienced than me. I had about 300 hours total time when I got my first kill. Some of these German pilots had thousands of hours, hundreds of combat missions, dozens of victories. They were legitimate aces, skilled warriors, and I killed them without them ever getting a shot at me. There's no honour in that. It was necessary. It shortened the war and saved Allied lives. But it wasn't heroic. It was technological murder, if such a thing exists. I was simply the operator of a superior machine." This moral ambiguity about technologically lopsided combat would resurface repeatedly in aviation history. American pilots in F-86 Sabres versus Korean War-era MiGs, Israeli pilots in modern fighters versus obsolete Arab aircraft, NATO pilots in the Gulf War shooting down Iraqi fighters that couldn't effectively fight back, all faced variations of the same ethical question. Is it really combat when the opponent has no realistic chance of success? The Meteor pilots confronted this question first, and their answer was pragmatic rather than philosophical. War isn't fair. It's not supposed to be. The purpose is to win with minimum friendly casualties. If technology gives you an overwhelming advantage, you use it. The enemy would do the same given the opportunity. Morality is a luxury you can afford after victory, not something you worry about during the fight. This pragmatic approach would define jet combat for decades, but it originated in the skies over Germany in early 1945, when Meteor pilots discovered they could kill with impunity. The technical intelligence gathered from captured Meteors after the war gave German engineers their first close look at British jet technology. What they found surprised them. The Meteor was in many ways less sophisticated than the Me-262. Its engines were simpler in design, producing less thrust. Its aerodynamics were more conventional, less optimized for high speed. Its systems were basic compared to the complex German fighter, yet it worked better. It flew more reliably. It was easier to maintain. It was more forgiving of pilot error. German engineers, trained to pursue technical excellence, struggled to understand how the British had achieved operational superiority with apparently inferior technology. The answer lay in manufacturing philosophy. British jet engines were designed to be produced with existing industrial capabilities and materials. German engines required specialised alloys and manufacturing techniques that were in short supply. British engines were designed to be field maintainable by ordinary mechanics. German engines required factory-level facilities to repair. British engines traded ultimate performance for reliability. German engines pushed every system to its limits. One German engineer, examining a Rolls-Royce Derwent engine in 1946, reportedly said, "This is not an engineering masterpiece. It is an engineering compromise. Every decision favours practicality over performance. The turbine blades are thicker than necessary, reducing efficiency but increasing durability. The bearings are oversized, adding weight but extending service life. The fuel system is simple and robust rather than optimized for maximum power. This engine will never set speed records, but it will run for 180 hours without major maintenance. Our Jumo 004 was the opposite, a masterpiece that barely worked. This was the British genius. Not superior engineering in the traditional sense, but superior understanding of what actually mattered in operational service. A jet fighter that flew 3 times as many sorties as a faster competitor was ultimately more effective regardless of performance specifications. The Meteor embodied this philosophy completely. The legacy of the Meteor's impact on German fighter pilots extended far beyond the war's end. In the 1950s, when West Germany began rebuilding its air force under NATO auspices, the psychological trauma of facing Allied jets influenced aircraft selection and training philosophy. German pilots insisted on jet fighters from the start, refusing to operate piston-engine aircraft even for training. They argued, quite reasonably, that any future conflict would involve jets, and preparing pilots in conventional aircraft would simply train them to be victims. This insistence on jet training from the beginning, while expensive and controversial, reflected the deep psychological scars left by the Meteor encounters. German pilots had learned that flying obsolete aircraft against modern opponents was suicide, and they were determined never to face that situation again. The Bundesluftwaffe, when it formed in 1956, became the first air force to train all its pilots on jets from initial flight training onward. This philosophy, born from bitter experience in 1945, eventually spread to other air forces worldwide. The Meteor itself continued in British service long after the war, but its most significant role was as an export fighter. Countries as diverse as Argentina, Australia, Belgium, Brazil, Denmark, Ecuador, Egypt, France, Israel, the Netherlands and Syria operated Meteors, often flying them in combat into the 1970s. The Israeli Air Force used Meteors during the 1956 Suez Crisis, and Egyptian Meteors fought in the 1948 Arab-Israeli War. These later combat operations revealed both the aircraft's enduring utility and its ultimate limitations. Against piston fighters, the Meteor remained dominant. Against first-generation jets like the MiG-15, it was outclassed. Against second-generation jets like the MiG-21, it was hopeless. The progression of jet fighter technology was breathtakingly rapid. An aircraft that had seemed revolutionary in 1944 was obsolete by 1955. This rapid technological advancement would characterize military aviation for the rest of the century, with each generation of fighters making the previous generation obsolete within a decade. The only surviving Luftwaffe pilot known to have kept detailed records of his encounters with Meteors was Oberleutnant Franz Stiegler, who flew both conventional fighters and Me-262s in the war's final months. His combat diary, published in 1994, provides extraordinary insight into how German pilots perceived and adapted to the jet threat. January 20th, 1945. First briefing about British jets. Intelligence says they're slower than our Me-262s, but more reliable. Orders are to avoid engagement if possible. Morale among the men is poor. We've been hearing rumours about Allied jets for weeks. Now it's confirmed. Another advantage lost. February 3rd, 1945. Saw my first Meteor today. We were climbing to intercept bombers when 4 twin-engine fighters appeared above us. They dove on our formation with incredible speed. Schneider was hit and exploded. The jets climbed away before we could react. The entire engagement lasted perhaps 10 seconds. These machines are terror weapons, not because they're so deadly, though they are, but because they make us feel helpless. We cannot touch them. They can kill us at will. February 18th, 1945. Another encounter. This time I was flying an Me-262. I spotted 4 Meteors at my altitude and turned toward them, thinking I could engage on equal terms. They immediately turned toward me and accelerated. I was flying the fastest fighter in the world at maximum power, and they were catching me. I dove away and escaped, but the psychological impact was severe. Even in our best aircraft, we're not safe. The British jet is not as fast as ours in level flight, but it accelerates better and climbs better. More importantly, it's always available. Our Me-262s are grounded more often than they fly. The British can always bring more jets. We cannot. March 9th, 1945. Lost 2 more men to Meteors today. Both were experienced pilots, over 50 victories each. They were bounced during climb and never had a chance. The squadron is refusing to fly missions where British jets have been reported. The commander is threatening courts-martial. But what's the point? We're not fighting to win anymore. We're fighting to survive until this madness ends. The jets are just another way to die. April 15, 1945. The end is near. Everyone knows it. Orders came to fly a ground attack mission against Allied forces near Bremen. 8 aircraft took off. 3 aborted, claiming mechanical problems. I led the remaining 5. We were attacked by Meteors before reaching the target. I survived by hiding in clouds. The others didn't. 5 experienced pilots dead. Their families will receive the standard letters about dying heroically for the fatherland. The truth is they were murdered by machines they couldn't fight. There's nothing heroic about technological mismatch. Stiegler survived the war and emigrated to Canada, where he became an airline pilot. In the 1980s, he met several British Meteor pilots at an aviation history conference. His reaction, recorded by an attendee, was telling. I expected to hate them. They killed my friends, my comrades, men I had flown with for years. But when I met them, I found they were just pilots like me, doing their jobs, trying to survive. The machines were terrible, the men were not. One pilot, a flight lieutenant who had shot down 4 of my squadron mates, apologized to me. Can you imagine? He apologized for winning. I told him there was nothing to apologize for. War is war. We would have done the same given the chance. But I also told him that those final months facing jets in obsolete fighters were the most terrifying of my life. Not because I feared death. I'd faced death 1,000 times, but because I felt helpless. A fighter pilot's life depends on skill and experience. Against jets, skill meant nothing. Experience meant nothing. You lived or died based on whether they saw you first. That helplessness, that knowledge that your fate was completely out of your control, was worse than any fear of death. The psychological impact of technological obsolescence that German pilots experienced in 1945 has been studied by military psychologists for decades. The phenomenon, sometimes called technological defeat syndrome, involves several characteristic symptoms: feelings of helplessness, loss of combat motivation, refusal to engage the enemy, and sometimes complete mental breakdown. Luftwaffe medical officers in early 1945 reported sharp increases in stress-related disorders among fighter pilots, particularly those who had encountered Allied jets. Some pilots developed what would now be recognized as PTSD symptoms, experiencing panic attacks when aircraft were mentioned. Others became fatalistic, accepting their deaths as inevitable and flying with reckless abandon. Still others simply refused to fly, preferring court-martial and execution to dying uselessly in unwinnable fights. The German military justice system, already harsh, became even more brutal in the war's final months as commanders tried to stem the tide of combat refusals. Pilots who refused missions were sometimes shot immediately as examples, but this only worsened morale, as surviving pilots realized they were considered more expendable than the aircraft they flew. The contrast with Allied pilots was stark. Meteor pilots flew with confidence bordering on invincibility. They knew they had overwhelming technological superiority. They knew that in any engagement with conventional fighters, they would almost certainly prevail. This confidence translated into aggressive tactics and high sortie rates. British jet pilots in early 1945 were flying 2 and sometimes 3 missions per day, far more than their German opponents could sustain. The psychological advantage of superior technology cannot be overstated. It affects everything from tactical decision-making to strategic planning to individual combat performance. A pilot who knows his aircraft is superior fights differently than one who knows his is inferior. The superior pilot fights aggressively, taking risks, pressing attacks. The inferior pilot fights defensively, avoiding engagement, seeking only to survive. The Meteor gave British pilots the confidence to be aggressive. The knowledge that Meteors existed gave German pilots reasons to be defensive. The psychological balance had shifted completely. In 1947, the Royal Air Force conducted an official study of Meteor operations during World War II. The report, declassified in 1972, provides fascinating insights into how the British viewed their jet fighters' impact. The Meteor's most significant contribution to victory was not the aircraft it destroyed, but the missions it disrupted and the morale damage it inflicted on enemy fighter forces. German fighter sortie rates declined sharply in areas where Meteors operated, even when jet encounters were statistically rare. Interrogations of captured Luftwaffe pilots revealed that fear of Allied jets was a primary factor in this decline. Many pilots reported that they would abort missions or refuse to engage Allied formations if jets were reported in the area. The Meteor thus achieved a force multiplication effect far beyond its actual combat performance. Approximately 100 operational Meteors effectively suppressed the activities of several thousand German conventional fighters simply through the threat of their presence. This represents perhaps the most cost-effective force multiplication achieved by any single weapon system during the war. The report continued with technical assessments that would influence British fighter design for decades. The Meteor demonstrated that operational reliability is more valuable than ultimate performance. The Me-262, while faster and more heavily armed, was significantly less effective due to poor reliability and high maintenance requirements. Future fighter designs should prioritize sortie generation rate over maximum speed. An aircraft that flies twice as many missions is more effective than one that flies 10% faster. The report also noted an unexpected finding about jet combat tactics. Contrary to expectations, jet versus piston combat did not require revolutionary new tactics. The basic principles of altitude advantage, energy management, and defensive maneuvering remained valid. What changed was the speed at which these tactics were executed, and the inevitability of jet victory when these principles were properly applied. A jet fighter with altitude and energy advantage over a piston fighter would win. Period. No amount of skill or experience could overcome the performance gap. This finding would prove prophetic in future conflicts from Korea to Vietnam to the Middle East, where jet versus jet combat validated the timeless nature of basic fighter tactics even as speeds increased dramatically. The lasting legacy of the Meteor in German military consciousness is evident in post-war aviation development. When Germany was permitted to rebuild its aerospace industry in the 1950s, the first priorities were jet engine research and high-speed aerodynamics, the exact technologies that had defeated them in 1945. German engineers who had worked on the Me-262 applied lessons learned from examining captured Meteors to create more reliable, more maintainable designs. The result was aircraft like the Fiat G91 and later the Panavia Tornado, fighters that combined German aerodynamic sophistication with British-influenced reliability engineering. This synthesis of design philosophies produced some of the most successful European military aircraft of the post-war era. But the deeper legacy was psychological. German military aviation never forgot the lesson of technological inferiority. Post-war German defense policy consistently prioritized maintaining technological parity with potential adversaries, even at enormous cost. The Luftwaffe would never again accept flying obsolete aircraft. This determination to maintain technological edge, born from the trauma of facing Meteors in 1945, shaped European defense policy throughout the Cold War and beyond. The last Meteor was retired from military service in 1983, when Ecuador finally withdrew its remaining aircraft. By then, the Meteor was a museum piece, an artifact from aviation's revolutionary transition from propellers to jets. But for German pilots who had faced them in 1945, the Meteor remained vivid in memory. At the final reunion of Luftwaffe veterans in 2005, one of the last surviving pilots who had encountered Meteors in combat, a man whose name was withheld for privacy, spoke about the experience. "I'm 87 years old now. I've had a good life since the war. I flew for Lufthansa for 30 years. I've been married for 60 years. I have grandchildren. But I still dream about those jets. Not nightmares exactly. Just dreams. I see them diving from above, impossibly fast, impossibly deadly. I feel again that helplessness, that knowledge that I'm about to die, and there's nothing I can do about it. Then I wake up and remember I survived. So many didn't. The Meteor was just a machine. Just metal and rivets and turbine blades. But to us, in those final months of the war, it was something more. It was proof that we had lost. Not just the war, but the future. Our technology, which had given us such advantages in 1939 and 1940, was obsolete. The enemy had surpassed us, and we knew we would never catch up. That knowledge, that certainty of defeat, was almost worse than the actual losses. When you know you cannot win, courage becomes just stubbornness. Skill becomes just delay. Fighting becomes just dying slowly instead of quickly. The Meteor taught us this lesson, and we died learning it. The transformation of German attitudes toward the Meteor from skepticism to terror to grudging respect mirrors the broader trajectory of the war itself. In early 1945, Germany still possessed experienced pilots, capable aircraft and tactical expertise. What they lacked was the industrial capacity to compete with Allied technological development. The Meteor symbolized this imbalance perfectly: a weapon that was good enough, produced in sufficient numbers, and operated effectively enough to achieve overwhelming superiority regardless of individual technical merits. When the British jet first appeared over Europe, German pilots assumed it would be inferior to their own Me-262, just as they had assumed earlier that American fighters would be inferior to German designs. This assumption was based on long experience of German technological superiority. But by 1945, the industrial balance had shifted irrevocably. Britain and America could afford to develop multiple jet programs simultaneously, testing different approaches, accepting failures, and iterating toward success. Germany could afford only one program, and it had to succeed immediately or the war was lost. This difference in resources, more than any difference in engineering skill, determined the outcome. The Meteor succeeded not because it was the best jet fighter that could be built in 1944, but because it was the best jet fighter that could be built, produced in quantity, maintained in field conditions, and flown by ordinary pilots with reasonable training. These operational considerations mattered more than pure performance, a lesson that would be relearned repeatedly in subsequent conflicts. The Me-262 was faster, more heavily armed, and more impressive in specifications. But specifications don't win wars. Operational sorties win wars. Aircraft that fly win wars. Pilots who come home and fly again the next day win wars. By these measures, the Meteor was superior despite its technical compromises. German pilots learned this lesson the hard way, and their testimonies provide the most compelling evidence of the Meteor's effectiveness. These were not rookie pilots confused by unfamiliar technology. They were veterans with hundreds of combat missions who could judge aircraft performance with expert precision. When they said the Meteor was terrifying, when they said it made them feel helpless, when they said it represented inevitable defeat, they were providing professional assessments based on hard experience. Their voices, recorded in combat reports, diaries, interrogations, and post-war interviews, testify to the Meteor's impact in ways that statistics cannot capture. The final word perhaps belongs to General Lieutenant Adolf Galland, who flew both German jets and captured Allied jets after the war, and had a unique perspective on the jet revolution. In a 1989 interview 2 years before his death, Galland reflected on the Meteor's place in aviation history. The Meteor was not the best jet of World War II. That honour belongs to the Me-262, which was faster, more advanced, and more capable. But the Meteor was the most important jet of World War II because it was the first jet to prove that jet fighters could be operationally effective, not just technically impressive. It showed that jets could be built in quantity, maintained in field conditions, and flown by ordinary pilots. It demonstrated that reliability mattered more than ultimate performance. These lessons shaped jet fighter development for the next 40 years. More personally, the Meteor was the aircraft that taught German pilots we had lost the technological war. We could build one Me-262. The Allies could build 100 Meteors. We could fly our jets occasionally. They could fly theirs daily. We had technical excellence. They had industrial might. In modern war, industrial might beats technical excellence every time. The Meteor proved this conclusively. Our pilots were speechless when they first encountered Meteors, not because the British jets were so technically advanced, but because they represented something we couldn't counter: unlimited Allied industrial capacity. We could build wonder weapons. They could build enough good weapons to make wonder weapons irrelevant. That's why we lost. And in that final assessment from one of history's greatest fighter pilots lies the true significance of the Gloster Meteor. It was not the fastest jet or the most advanced jet or the most heavily armed jet. It was simply the jet that worked, produced in numbers sufficient to matter, operated reliably enough to dominate, and feared enough by the enemy to change their behaviour even when it wasn't present. The German pilots who faced Meteors in 1945 were speechless, not because they lacked words, but because they recognised in those blunt-nosed British jets the future of aerial warfare, and understood that Germany had no place in that future. The propeller age was over, the jet age had begun, and Germany had lost the race to own it. The sky belonged to the jets, and the jets belonged to the Allies. Everything else was just counting the days until the inevitable end.